Welcome to this lecture on classification of motors. In this lecture, we are basically going to describe you some of the different types of motors and their applications. Now, motors can be broadly classified into three categories, namely DC motors, AC motors, and some special motors. Again, DC motors can be PMDC motors. PMDC means permanent magnet DC motors, DC shunt motors, DC series motors, and DC compound motors. Okay, these are the different types of DC motors. AC motors again broadly classified into synchronous motor and asynchronous motor. Asynchronous motors are also called induction motors. In the category of special motors, there are servo motors, stepper motors, universal motor, and BLDC motor. BLDC means brushless DC motors. Now let us see one by one all these different kinds of motors. So first we'll start with the DC motors category. First is permanent magnet DC motor. Now permanent magnet DC motor, you can see this one is one of the example. This is a generally very small and very cheap motor, and you can see the name itself tells it is permanent magnet. That means the stator is permanent magnet, whereas the armature winding is there where basically the shaft is connected. Okay, and the applications you can see in toys, small hand tools, wipers, blower in electric heaters. These permanent magnet DC motors are widely used. In small Arduino projects also these permanent magnet DC motors can be used. Now come to the DC shunt motors. Now in the last category we have seen that permanent magnet DC motor where the stator was permanent magnet. Okay, in DC shunt motor the stator was not permanent magnet, but the field current is provided to produce the electromagnet in the stator. But both the armature and the field current are coming from the common source, common DC source. Here you can see from the common DC source both the field current, this field current is creating stator electromagnet, and this is the armature where basically the shaft is connected. Okay, so both are connected in parallel, and that is why it is the shunt motor, because the field winding, this is called the field winding, which is basically the stator winding or the field winding, which is parallel to the armature. That is why it is the shunt motor. Here you can see the inner picture of the DC shunt motor. This portion you can see, this is nothing but the commutator. That is why this is the DC motor. Commutator is there, and you can see the armature winding. So let us see this picture, and here you can see this is the field windings. Here you can see these are the field windings. Okay, what is the specialty of the DC shunt motor? The specialty you can see from the top characteristic curve. Here in the y-axis it is the speed in RPM, and in the x-axis it is the torque. And you can see even with the increase of torque or the load, the speed is hardly sacrificed. That means the speed is almost constant. Okay, so it can maintain a constant speed even at a very high load or torque. Okay, it has wide application because of its constant speed characteristics, like in lathes, milling machines this can be used, or vacuum cleaners, pressure blowers, compressors, reciprocating pumps. Okay, woodworking machines such as circular saw, wood planers, laundry washing machine. So these can be used. Now come to the DC series motor. The name itself tells that in this case also the field winding and armature winding are getting current from the same power source, and this field winding and the armature are connected in series. That is why the name is DC series motor. And here you can see this is the field winding. If you compare with the shunt motor, the field winding wears in case of series motors are thick in comparison to the shunt motor wears. Okay, and here you can see the speed torque characteristic curve, and the specialty that you can see over here in DC series motor, that at a low speed, even at a very low speed, you can see high torque can take very high torque. That means initial high torque, the initial high starting torque it can take. Okay, so at a very low speed it can take very high torque. This is what is the specialty, and that is why these are suitable for the traction purpose. In earlier days, the railway engines, electric engines were made of DC series motor. Recent time basically the AC induction motors are used, but these were very common earlier days. Anyway, for the traction purpose in railways, rolling mills. In rolling mills, what happens that it is not important to maintain the constant speed, but what is important that in case of when the steel billets are coming, okay, through the different mills, and its thickness is gradually reducing when they are passing through different mills, so sudden loads are coming when the large thickness are coming into the rollers. So that is why at that time the torque becomes very high, and to take those torques, this kind of series motors are suitable. Here you can see another example for mine hoisting purpose. Coal or other minerals, when they are taken out from the underground, then a huge torque is required. Okay, continuous conveyors, also cranes, they uses DC series motor. Now coming to the DC compound motors, here if you see the circuitry diagram, you can see the field winding is one part is in series with the armature and other part is in parallel. Okay, so it is basically trying to take the advantage of both the series and the shunt effect. Okay, so this is what is called compound motors, and it has wide applications, and here you can see those are listed, like in compressor, stamping machines, pressure blowers, toll lifts, okay, rotary presses, flatbed press, metal planer, shearing machines, punch press, rolling mills, flight elevators. So lot of applications are there in case of DC compound motors. Now coming to the AC motors. Okay, so we have covered the different kinds of DC motors. Now come to the AC motors. The first is the synchronous motor, and then we'll see what is asynchronous. In case of a synchronous motor, basically the stator and the rotor rotates at the same speed. Okay, the stator and rotor rotates at the same speed. That is why it is called synchronous. Okay, and speed depends on frequency and the poles. Okay, the supply frequency and number of poles present, the speed depends on that. Okay, by changing the frequency, it is possible to change the speeds in case of synchronous motor, and speed remains constant irrespective of load. So this is the great advantage of the synchronous motor, that the speed remains constant irrespective of the load. If the load is too high, more than its capability, then this motor actually stops, but it do not sacrifice with its speed. Okay, so speed always remains constant. You can see its applications like ammonia and air compressor, continuous rolling mills, medium and large drives in the paper and the cement mills. Okay, voltage control at the end of transmission line, large fans, large compressors, large line shafts, large pumps. There synchronous motors are used, where constant speed is very important. Now come to the asynchronous motor. Asynchronous motors are also called induction motors. This can be of two kinds, single phase induction motor or three phase induction motor. In a single phase induction motor, you can see some of the examples. Remember that single phase induction motor is not self-starting, but three phase induction motor is self-starting. So for the starting purpose, for the single phase induction motor, some kind of either resistors or capacitors are used. Okay, and remember in this case the stators stator is rotating at a higher speed with respect to the rotor. Rotor is rotating at a lower speed and the stator is rotating at a higher speed. In case of induction motors, their speeds are different, like stator and rotor having different speed. That is why they are also called asynchronous motor. Okay, now these are used in centrifugal pump motors. Okay, both single phase and three phase motors. For the smaller capacity pumps, like our household pump to take water in the overhead tank, we use generally the single phase. But for the large industrial pumps, may be operated by three phase induction motors. Okay, here you can see single phase, if it is less than 3 to 5 kilowatt application and not self starting. So single phase induction motors again can be resistant start. I have told you already, single phase induction motors do not start, they are not self starting. That is why some starting elements are required, like resistant start, capacitance start, or capacitor start, capacitor run, or a permanent capacitor kind. Okay, this permanent capacitor single phase induction motor is very common, like in desert cooler or in a ceiling fan in our room. Basically this particular motor is used. It's a single phase induction motor and permanent capacitor kind. Now three phase induction motors, they are self starting and they are generally capable of large power, more than 3 to 5 kilowatt, and they can maintain, they can be of two kinds: squirrel cage induction motor or slip ring induction motors. Slip ring induction motors are high starting torque applications. They are used mainly for lift, railway traction, elevators. They are basically these slip ring kind of motors are used. Whereas squirrel cage induction motors, they maintain a constant speed, and that is why they are suitable for this centrifugal pump, maybe the large centrifugal pump. Three phase induction motors, squirrel cage are common. Okay, now coming to the special motors, first we will see what is servo motors. Okay, servo motors is a motor which is working in a closed loop pattern. Okay, so already within that motor there is a closed loop control is present, and these are having a different use in robotics. It has use in industrial applications, CNC machines. These motors are widely used because of its high accuracy and a closed loop control. High accuracy and precision control robots, but most of the cases the objective is not a very high speed application but high accuracy and precise control. Okay, for that we use this kind of motors, where you can see the shaft is rotating with the help of this motor. Then exact position of the shaft or the speed of the shaft is feedback to the drive, and accordingly the correction is taken place. So within that there is a feedback mechanism present. That means one sensor is already there within the servo motors. Okay, now you see some of the applications like rotary actuators, linear actuators. Here you can see robotic arms, control surfaces in aeroplane. For industrial applications, you can see the linear actuators can be used for this kind of a bottling plant, maybe placing a bottle, filling some liquid within the bottle, and then the cap is sealed. So this kind of operation can be done with the help of servo motors. They are precisely controlled. This linear actuation motion can be controlled. Here you can see some of the process in assembly line operations that is going on. Some linear actuation is taking place. So all these are controlled by the servo motors. Now what is there within the servo motor? It's a simple one. This is a small servo motor. So you can see, suppose it is a DC servo motor. Remember, the basic motor can be DC, can be AC, different kinds of motor can be there in a servo motor, but the servo basically indicates there is a mechanism of feedback that is inherent within the motor. So here you can see, suppose this is a DC motor, and we know DC motor is a high speed low torque motor. To first of all, to make it a high torque, a gearing system is arranged. Okay, with the help of gearing it is possible to increase the torque. Okay, definitely the speed will be reduced, but the torque will increase. And we have already told servos are not meant for high speed, so that is why speed is reduced and torque is increased with the help of this gearbox. Now the feedback is to be given, so some sensor element is required. Here you can see one potentiometer is there, and the potentiometer knob or wiper, you can say, is directly connected to the shaft, the final gear shaft. So then what will happen, exact position of the rotation then will change the knob of the potentiometer, and that signal will go to a particular microcontroller, and accordingly the correction signal or the controller signal will be given to the motor, and accordingly the speed or the position will be adjusted, and that is why it is so accurate. So here you can see what is the closed loop system within the servo motor. Here you can see this is the basic motor, and this one is connected at the end, which is the encoder. Encoder is basically a sensor that sends the position and the speed of the motor. Okay, so the example that we have just seen, the potentiometer was acting as mechanical encoder. Encoder can be of different kinds. It can be optical encoder, it can be of electromagnetic encoder like Hall effect encoder. So but there are many other forms of advanced encoders are also there, but this one is a very simple mechanical encoder potentiometer. Now see what happens. This potentiometer or the encoder sends what is the exact position of the shaft or the speed of the shaft, and then that information is given to, and it is compared with the sensed position or the set position, and according to the error signal, controller send the signal to the motor to correct its speed or the position, and in this way then the motor with the help of gear actually increases the torque and reduces the speed, and ultimately the final positions become very accurate. This is what is the servo mechanism in short. Now you can see different applications like in robotic arm, all these arm joints there are servo motors. Okay, or you can see the in CNC machining or different machining, this kind of motors are used for the actuation of different components. Here you can see in the antenna, the rotation of these antennas are controlled by this kind of servo motors. Okay. Now another kind is the stepper motor. Stepper motor is very precisely controlled again, and these are operated in steps. Here you can see, suppose these are the magnetic fields. Look at this diagram, and you can see these are the poles, and alternately the signal is processed in such a way that this polarity is continuously changing, and as the polarity is changing depending upon north and south alternate poles, you can see it is rotating in a particular direction in a very small steps, and these steps can be very small, maybe 0.9 degree steps. Okay, so in that way very precisely it is possible to control the position of the shaft. Okay, and these are used in robotic arms. These are very accurate, but this is an open loop system. This is not a closed loop system like servos. Servos are more accurate and closed loop system, but stepper motors are not so accurate like servos, but these are also used in different robotic applications. But remember, this one is cheaper with respect to servos because there is no sensor or feedback kind of a thing. It is open loop system, but this is also very accurate. Okay, here you can see the different electromagnetic poles are changed by changing their input, and this is controlled by some microcontroller. Okay, but this is pre-calculated thing. That means it is not a feedback control kind, it is an open loop system. Now stepper motor, you can see the different applications like in robotic arms, in printers, inkjet printers, these are used, and camera zoom lens movement, stepper motors are used. Integrated circuit fabrication, stepper motors are used. Now another kind of special motor, it is universal motor. The name universal came from the fact it works in both AC and DC. Okay, these are generally high speed motors, and example in mixer you will find this kind of universal motor. Now brushless DC motor, these are probably the future motors for many applications going to be, and already you can see these are very suitable for the drones, and these motors are used. And in these motors basically rotor and stators are basically reversed. That means the so it is actually working in the form of a induction motor kind of a thing. Okay, let us not go into the detail of how the brushless DC motor works, but this is very effective one for many applications. Thank you.